Hello and welcome to our workshop. It's Multiplatform Compose and SwiftUI, the native app future. I'm Kevin, and with me today we're going to have Gabriel and Gustavo, who did the bulk of the work on the code. I'm going to give you a little talk on more of the business and background case, and then we'll jump into doing a lot of the code. You can check out in the YouTube description the link to, we have a blog post about this that includes the repo you can go to and whatever you'll need to get started. We did this live at Kotlin Conf. We're assuming that most people aren't going to do it live on a Zoom call. But if you are, please check that out very quickly, and maybe it'll be set up before I'm done talking. So why are we here? Why are we doing this? Why are we talking about this? Why is this an issue? So KMP is, I would say from the beginning, very known for what I would argue was the killer app, which is you can share native mobile, Android and iOS logic, but not really UI, right? And the reasons why this is better than other things, KMP has less distance, and distance I define in the shared code terms as the difficulty in using some other shared code. So maybe it's bad interop, or it's a different language, or a different team builds it, no community or libraries or whatever. Right. Most shared code is not used very much because it's very painful and expensive to do so. KMP really changes that situation. So it really shortens the distance. So you have great interop, which means you can have incremental adoption, optional usage, which is, you can use some here or not there. You can do something in KMP and then carve it out native later if you need to, that kind of thing. It is platform native for Android, as in, it's not cross-platform on Android. You would do Kotlin anyway. And all that kind of adds up into what we would call a low-risk option. You can try it out with low risk. You can increase your adoption. You don't have to make big decisions. So what we're talking about today is optionally shared UI, which is really taking those same concepts and pushing them up into the UI, right? And it is what we would call a low-risk option for doing a shared UI implementation. And you can mix Compose, you can mix SwiftUI or UI Kit. You can have the shared KMP architecture underneath it, so you can swap out screens if you want incrementally. And all that wraps up into, again, a low-risk option to do a native app as native as you want it, but is really a cross-platform app. And you might say, well, great, 10% of the screens, 20% of the screens are native, so it's a 20% native app. And it's no. There's this concept that we're calling 80-20 UI, but it's even really more stark than that. It's usually more like 90-10, where in most apps, your users are mostly on a handful of core screens. And then the everything else screens, right? So in this case, this is actually Apple Health, who are probably not watching this talk or going to be using Kotlin anytime soon. But the point can be made pretty easily. The screen on the left, I'm sure that there were focus groups and endless meetings of designers to discuss the radius of the line cap of the charts, right? Because this is the main core screen. And then on the right, it's, if you took off the browse thing at the top, I'm not sure if you flashed it to an Android or iOS developer, they'd be able to tell you which platform it's on. And most users probably won't see. It's a maze of setting screens. So, do those in Compose, do the main screens in SwiftUI or UI Kit, and that's the concept. And really, at the end of it, your users get an almost entirely native experience because they're spending almost all of their time on the core screens. But you, as your team is doing almost entirely shared code in theory, right? And again, I would say it only matters for iOS, because on the Android side, this is all native. So this isn't even, there's no 90% about any of it over there. So that's what we're trying to do here. And native is better. Why? I'm not really saying that as a statement. It is just sort of something that people say, and it's kind of known, right? So native devs would say, well, users want native. I hear that a lot. And okay, but unless you are a native dev, you really have no idea how native apps are built, or anything is built, really. So users don't really know what native means. But they do know when things don't feel right. And you can also tell when it's not really platform native, like, okay, this thing's a little weird, but if it's a utility app and you got to use it, whatever. But if you really want to give a good experience for your users, native is usually the choice. The other side of this equation is like, for these things, somebody has to make a technical decision, or somebody has to really advocate for something. And if management, quote unquote, wants to go with some one thing that's, safe or whatever, they have a reason to make one decision, and you really advocate for something else. Well, now you own that. And it's like, it's risky. And in larger orgs, this is definitely a thing. So if you pick a technology that is, has no escape route, like if you build it with Flutter or React Native, not to say these things are bad, but if you get to the end of the build and it's not doing what you need, the answer is kind of a rewrite, So even if the technology choice wasn't really the problem for the failure of a product, like if you really advocate for something that people didn't want and it doesn't go well, maybe that gets blamed for it. So it's kind of like it's a little CYA if you've spent any time in corporate land, and optionally shared UI gives you an out because you can. It's like, well, this isn't working. Let's redo all the screens in native if you got it. So, but that doesn't matter. The why doesn't matter. You would pick native if you could, and if you wouldn't, it's not because you don't want native, it's for some other reason, right? Like maybe you have a whole bunch of features and you want to keep feature parity, and that trumps, the native perfect look and feel kind of thing. Like that makes sense, but this approach actually steps around that as well. Maybe your team is experienced with another technology, or their web devs or whatever, but if you could wave a magic wand, you'd pick native, right? That's a pretty safe assumption. So optionally shared UI, goals, build features with maximum efficiency, as native of an experience as you need, and remove as much risk as possible in the decision and the implementation, right? So if you want to quote, cross-platform efficiency, native experience by me. Okay. So this isn't a future far off thing. This is happening now. We're doing this, and more formally, more specifically, Gustavo is doing this. So I'm going to let him talk about this for a bit.
Okay, and I know that this may look something from the future that's not happening right now, but that's not true. We are working with a large org that has multiple public apps, is using KMP for the last 3 years, and recently decided to experiment with Compose Multiplatform. We built them a good backup plan. If they decide to roll back and didn't like the Compose, they could, but the idea is to migrate the whole SDK to Compose Multiplatform, have one unified UI that would be beneficial for them. It's one implementation, lower the risks of parity issues, so only benefits. And we can do this in a incremental migration, so they can do step by step and don't need to stop everything and do all at once.
Okay, so what is the Code Lab going to do? It is a restaurant app, and it's a restaurant app that has restaurants that were around Copenhagen, because we were at Copenhagen. We gave the warning there, don't try to go to them because it was sourced from ChatGPT, and spot checking a couple of them close-ish, just assume that they're not real, but anyway, that's not important. It is using Voyager for navigation. Just interesting fact, Gabriel, who's also going to be talking, he really does the bulk of Voyager's maintenance at this point, and most of the commits and management. So Voyager was obviously an easy choice. We're going to use Jetpack's view model, the newly multi-platform view model. And we're going to use Sky, which we're going to have another code lab about Sky. Sky essentially takes the Objective-C kind of dumbed down interface that comes out of KMP and adds a lot of the modern features that Swift engineers would expect, and type safety and all that stuff. But that's a different talk.
Cool. Now that we know what the app is, let's start mixing some elements and developing a new feature. For that, let's pretend the project manager has to add a map in the detail screen. As a developer, probably the first thing you're going to do is Google about libraries that you can use with maps and Compose. One solution that you'll probably find is the Google Maps API, but unfortunately that's Android only, so you can actually use on multi-platform projects. So you go back to Google, update your query, and search for an iOS version. but unfortunately we don't have anything yet. But you'll discover that MapKit, the map APIs from Apple, works with SwiftUI, and you know that Compose can also interrupt with SwiftUI in some way. So maybe we can do is use the expect actual feature from Kotlin Multiplatform to implement this. And on Android we just use Google Maps, and on iOS we use SwiftUI and the MapKit implementation. A couple weeks ago we posted a blog post showing how to interop with the native components on iOS. If you haven't checked that, no problem, we will cover it here. So the first thing to know is that Compose doesn't talk directly to SwiftUI. Compose only knows how to talk with UIKit, and SwiftUI also only knows how to talk with UIKit. So to make Compose and SwiftUI communicate, you need to go to this middle layer, or this common denominator, there is UIKit. For that, we use the UIKit view controller on the Compose side. It renders a view controller, as you can see, and all you need to do to render a SwiftUI method is to convert your SwiftUI to UIKit. And for that, official documentation from Apple suggests using the UI hosting controller. It just converts a SwiftUI view into a view controller compatible with UIKit. Here is the function, the composable function from our map. It will have the modifier, it will have the coordinates and a title for that location, because it's information from the restaurant. Now we are going to render this UIKit view controller, and we will provide in the factory method the view controller we want to render. There is the MapKit view. But unfortunately, how we don't have access to that on Compose. So how can we fix this? How can we provide this value? Well, the factory name gives us a hint. This factory is the factory design pattern. So one thing that we can do is kind of leverage this in a way. We can create an interface factory that has a factory method to create this map view. It will return a view controller as we need, and implement this interface on the Swift side. So Swift knows how to implement it. It will create this view controller for us and return. And on the Compose side, we only have the interface instance. To receive that instance on the KMP side, we can use the view controller that we exposed to Swift. We can just add a new argument there. That is the view factory. We can add it to the local compositions, so we can access anywhere in the Compose tree. And then back to our composable map, we can just consume this factory from the local compositions and link the factory from the UIKit view controller to our new factory that we implemented. So with that in mind, let's start doing the first part of the coding exercise. For that, let's jump to Android Studio. Cool. Now we are here on Android Studio with the project open. As you can see, we have a list of restaurants, and when we click in one, we have the information. And what we want to do is add a map here to the bottom. For that, the first thing we need to do is create the expect declaration on the common main. So in the common main, go to UI, components native. We have this map view file created with the same composable function we showed on the slides. So just uncomment it. It will complain that there is missing extra implementation. We will do that in a moment. First, let's go to the detail screen. So go to screen, details, detail screen. And we want to add the map to the bottom, and we already have this comment declaration here. Just uncomment, and it will just add to the bottom of this column. Now in the map view, let's start implementing the Android version. For that, hit Option Enter, add missing actual, select Android main, hit OK. It will generate the file. Probably you need to import the annotation. And as we discussed, we want to use the Google Map. For that, we have this Google Map view pre-created. It will just create a Google Map and add a marker with the place in the map. So all you need to do, as you can see here, it uses the same the same parameters, so all you need to do is call this composable. So just call Google map view and pass the modifier, the place name, and the coordinates. When you run your project, you can see that when you open any restaurant, it will have a map, and if you go to a different restaurant, it will have the other restaurant information. So on Android, problem solved, it's working. Let's start working on iOS. For that, we need to do the same as Android. Hit Option Enter, add missing actual, but for iOS, select iOS main. It will create a file, and all you need to do for now is call this mapkit view. To follow a similar approach with Android, we extract the implementation to another composable to not implement everything in the expect actual. So all you need to do is call this mapkit view. It has the same parameters, and it uses the UI kit view controller. So call mapkit view, and same parameters: modifier, place name, and coordinate. But different from Android, here we need to do some implementation. As you can see, our factory just have a to-do. And as we discussed, we will need an interface with a factory method and receive that factory method on the constructor from our view controller. For that, we have a pre-created file, native view factory. It's just an empty interface for now with the commented methods. Just uncomment the create map view. That's the method we need. It will get the 2 parameters and return a view controller. To receive that on the view controller, it's already added to the parameter, so you don't need to do anything, and we already have a composition locale that you can use. So you can just call the local native factory and it will be there. So returning to our iOS implementation, now we can get factory local view factor.current to get the instance, and then in this factory method we need to call the method from this factor instance. So factor.createMapView, and the place name and coordinates are the parameters. Now we need to go to Xcode and implement this interface so we can run the project. Cool, now we are here on Xcode with our iOS simulator open, and as you can see we have the app in the same state from Android initially. When you click in the option, you can see that there is no map. We want to add the map here. So when we go to Xcode, the first thing you will notice is that the native view factory implementation does not confirm the protocol because it's missing the method. For that, just uncomment the method we declared on the common code, and it will stop complaining, but it will complain that we need to return the view controller. But first we need the SwiftUI view for that. To help you, we already implement this native map view SwiftUI view. It will render a map and add some annotation. The annotation is the ping in the map, so you can show something similar from what we have on Android. All we need to do then is create our view instance. So just put let view, and it will be the native map view. Place name and coordinate are the parameters that we received. So all we need to do is pass, and then we need to return our UI hosting controller using the root view being our map view. To link everything and pass this interface to the common code, our iOS app here is already doing that. So when we call the main view controller, we already send this interface instance. So we don't need to do anything else. Just run the project, and now you will see that the map will be available for you. Cool. So when we click on the first option, you can see that there is the map information there, and we can go to another one, let's say Sunset Boulevard, and you can see it also has information as we expect there.
So in this next exercise, we will be implementing the list screen with SwiftUI. So let's back to the Android Studio, and we will open the list screen. We can see here that this is a Voyager screen, as the tail screen is. The content of the Voyager screen here, we fed the Voyager navigator, we fed the view model, and we pass to this list screen content that is where it's being rendered. So we pass it to the modifier, the view model, and we pass a callback to it to do the navigation and to the detail screen. The list screen content basically collects the state of the restaurant. It's a lazy column, pretty standard Compose UI that renders the list of restaurants that is fetched from the restaurant from the view model, right? So if you go to the view model here, we can see that it's just a state flow that we are collecting. Is state flow of a list of restaurants, and then we passed it to the lazy column items and render this restaurant list item. So what we want to do is on the iOS, we want to implement this with SwiftUI. So as we did previously for the map view, we need to define an expect function. So we can go here and start writing like expect function for it. So we need list screen content and we call it native. This needs to have the same signature that we are rendering in Compose. So we can copy this here and place right. And then we can update the list screen here to use this new expect function that we have. So we will add the missing actual for Android, and what we will do is basically call that previous. So modifier, view model, and on restaurant. We can run the Android here to see what is the result. So everything is working as expected. Cool. We now can implement the iOS actual. So iOS main to import, and as we Gustavo had show us, we need to fat from the local composition the native view model factory. Import it and use the UI kit view controller composable. So we can pass the factory here, but we still don't have not implemented it. So we can go to the native view factory on iOS. We have this snippet already here to uncomment. So it receives the list view model and the callback for later on the SwiftUI call this when the user clicks on the restaurant card. So we can now call this factory positive model that we are receiving and the callback. Cool. Basically, that's it that we need to implement on the Android side. So we can go to Xcode, we can open the native factory, and we have this snippet to that is the override function. So this is basically the override function. So we have the list view model here, the restaurant click, and we need to return a UI view controller. So we will do the same previous thing that we have did to the map view. So we need to return a UI view controller for the SwiftUI. We need to wrap this inside the UI hosting controller. We have implemented this list screen content view that is pretty similar to how the Compose one is implemented. So we have this list component that's basically the list column that receives a list of restaurants. That is this state right here. Same. So this is a state like in Compose we have a state or the by delegate for fetching the states. And inside the list content for each restaurant, we render this restaurant list item. we pass the restaurant, and it has a callback. So pretty similar to how Compose is written, right? But different. What we don't have here is basically the state observation. In Compose, we have the collect as a state on the view model. In SwiftUI, we are also receiving the view model and the on restaurant click here. But we are not collecting to this variable, to this state. So for collecting the state flow into the Swift UI state, we can use the sky preview function that is called collect. And this function that comes from sky, we can pass the flow, the sky Swift flow protocol here, and we can bind to a state. So we can call view model and restaurant. That's basically the view model that comes from Kotlin, right? That return for us a state flow, and we can put this into the restaurant state. So this dollar here is for binding to the restaurant state right here. So every time this there is a new flow state, it will be updated to the restaurant state in SwiftUI. So this is a preview function that from Sky 0.8. For enabling it, we go to build Gradle settings here, and right here we have this enable SwiftUI observing preview. That's basically it. To use this new Sky awesome feature. Cool. Now that we have done this, we need to go back to the native view factory and update to return to Compose the SwiftUI view to Compose be able to handle it. So we need to create this view. So we will instantiate create the list screen content here, pass the list view model and the restaurant click, and then we need to return our UI host controller here. So pass view, and that's it. That's basically it. We can run the application now and see how it will work. So sliding it to build. And that's it. We have a screen completely written in SwiftUI. But one thing that we will see here is that if you scroll down here and click for navigate and go back, we lost the scroll position. This happens because when you navigate to another screen, Compose will remove the whole content, and we will lose the reference to the UI hosting controller, the UI view controller that is being displayed there. So for fixing this, we need to keep the view controller when we are handling it. We need to keep the UI view controller when we are handling it for when the screen is on the stack, right? For doing this, we can go back to Android Studio, and on the list screen implementation for iOS, we need to basically hold this instance that we are creating here inside, for example, on our object that will survive until this screen is on the stack, right? And basically implement API that does this, that keeps the object when is in the stack, is the view model, right? So we can create a new view model. So for example, native view controller holder, and implement the view model here. If this feels weird to kind of controller, if this feel weird to use a view model for this is pretty fine. because view model basically is a component that survives configuration change on Android, and for Compose especially, it survives decomposition. So when your screen is in the stack, it will survive, be on the stack, and when your screen is removed from the stack, it will lose the reference for the view model. So this is basically what we want. We want to keep the UI view controller until the screen is in the stack, for allowing us to keep a SwiftUI state as it is, because we can't have implementation in SwiftUI that had its own states, everything there in SwiftUI. So we want to keep this, so we can hold this UI view controller inside the view model. So we basically go here, define a view model, and we call view model here. I don't know. Import it. And we need to call the native view controller holder that we have built. And instead of calling this here, we will call here to here, and now we can call the view model UI view. And that's it. Now we can run it again. Let's run it again on Xcode, and we will see that the scroll state is being kept. So every SwiftUI state that is being on in SwiftUI will be kept. So we can scroll down, click here, and go navigation back, and the screen position, the scroll position is kept. So pretty cool. So basically that's it for that we need to do. So here we are. We have a screen that is using a SwiftUI component, and we have a screen that is built entirely with SwiftUI and collecting states directly from the view model, right? And so doing a recap and on the technical parts, we can use the UIKit view controller composable for displaying SwiftUI views, but we need to have pass this SwiftUI view to Compose, and we can use a factory method to do so.
Okay, status and future. You can do this now, obviously, but it's not, everything is not perfect, right? There's compromises. So Compose host issues, but really they're Compose issues. I mean, Compose is new, Compose Multiplatform. It did hit beta. It works good, but it is obviously, I mean, if you really did heavy stuff side by side with native views or SwiftUI or UIKit, you would probably notice something. Accessibility, I think, is something that is obviously improving over time, but there have been issues. Styling, I mean, it's not a platform native thing, and you got to figure that out. View libraries, I mean, there's a lot of Compose view libraries, not necessarily Compose multi-platform view libraries, so that is an issue. Tooling, we don't need to go into detail there, but obviously this is new, and it's something that, it's improving, but it's definitely new. So native nav, iOS really wants to own it, and this isn't a dig on iOS. I mean, on Android has its own Androidisms, and engineers aren't writing all the swipes and the stuff you expect for navigation. Same on iOS. So Compose Host can try to simulate these things, but I've talked to people who are Android engineers who are like doing it really with Swift Host, and they're embedding Compose views just because they really want a native app, and they don't want to try to like figure all that stuff out. And it's definitely more work, but as I say here, don't repeat yourself can have diminishing returns if you take it to extremes. Other stuff, native views are just optimized. I mean, I don't know how to say it any other way than that. You get back to like, well, what does native mean? It's like, well, let's talk in a year. When Compose is stable. I don't know. The counter argument, it does make sense. SwiftUI is tied to the OS, which really sucks, and I didn't understand why they were doing that. Because yes, iOS developers or users tend to be up to date, but that's really frustrating that, you have to worry about that. And all is not great in SwiftUI land if you talk to the iOS devs. I mean, it's improved, but it's not perfect. Anyway, that's a long rant on the reason that's great if it's tied in the OS is due to the next thing, which is when you want to have an initial render of the screen, it takes a while because especially in Compose Multiplatform, you have to load all that stuff. And it's nowhere near as optimized as it maybe is on Android. And even on Android, some teams could see Christina Lee's talk last year at Kotlin Conf 2023 about loading times and why not everyone uses Compose on Android. So on iOS, it is more of a thing. It's not terrible, but you know what I'm saying. And any Compose you put in there is going to add a 20 to 30 meg tax on your impact, on your binary size impact for your app. That's just sort of table stakes, and that's Skia. That's other things that have to get bundled in there, which is unfortunate, but it's true, and it's just something you have to deal with. So maybe that'll get improved over time. I don't know. But the argument that iOS apps are huge anyway. I'm like, yeah, but some apps are more sensitive to binary size issues than others. So it's a thing. Yet it's an amazing platform. But it whether you use it is really, and how amazing it is a function of context and time. So it's very, very new technology. It's like a nice new house, and you got nowhere to sit down, right? Like a lot of stuff has to happen. The community really needs to come together and both build libraries that are necessary to do this mixed work, not to mention just Compose multi-platform libraries, but to do this blended stuff, and best practices, which is, always ongoing. I mean, navigation all Compose navigation is designed with the idea that you're going to just do Compose, but maybe you're not. Where do you put your strings? I mean, that's already an unending debate for KMP. Well, now add something on top of it, right? Where are the architectural borders, which is something you should see the next code lab that I'm really going to be focused on is how teams deal with things, and the Android iOS border becomes something to discuss formally there, and context specific approaches. I mean, like a lot of advice in anything in KMP, but this is true of any new technical ecosystem. The advice is all generic, like, well, how does a team use this? Like, oh, do this. And what do I do with this? Well, you do that. And as you mature, you have to say, well, if you're doing this and this, and you want this, then you should look at this, else do this. Like, we need context specific best practice. We have a general problem in KMP, which is the whole thing is basically Android-y. Like top to bottom, everything's Android centric. So, having Swift technical knowledge doesn't mean you understand iOS dev. And, even the Android community doesn't internally agree. Like, look up whether we need a view model. Primarily, I would say Chris Baines is the standard bearer for the no, we don't. So if the Android community doesn't agree on this, then the official libraries coming out with view model, maybe they're a little Android-y. So I think that needs to be kind of sorted out. And Android is fine until you get to the border again, and the border is a big topic. See that next thing. Blended UI though has much more border associated with it. So if you're choosing between these things, I mean, again, context specific, Compose host is going to be, you can have isolated iOS views, data in and out. Otherwise they're ephemeral. It's probably a very Android leaning team. You have homogeneous architecture, and that's, it's more straightforward. Swift host, I mean, how you build iOS apps, whether you're using SwiftUI or, UI kit, there's different architecture patterns. There's certainly, differences to lifecycle, community conventions, and your own team's conventions. They're going to be very different. It's likely a blended team of Android and iOS engineers, right? So this is going to be, it's a very different context, and you got to make your decisions based on that context and what you're looking for an outcome. I will say this is my call to arms. If you are an iOS developer and you would, you're trying to make your name for yourself in the iOS community, the same thing I said to KMP people early on. If you're an Android developer and you want to make your name for yourself in the Android community, it's very crowded, but KMP is wide open, and Compose multi-platform, especially with this kind of blended UI thing. If you're really an iOS developer, I mean, KMP in general, if you're an iOS developer, become a KMP iOS expert, write some blogs, make some few videos. We're desperate for true KMP understanding to come in and work on these things. But again, that's a topic for the next section. Context is crucial finally in this discussion. A lot of people are absolutists, like, well, KMP will never win or Compose will never to be the thing. And it's like not everything is for everybody. Uber and Facebook are probably not watching this video or considering shared UI. I'm stealing some charts from an earlier talk I did. Back in 2014, if you said complexity versus what's native versus what you should do native versus not. I mean, anything remotely complex, everyone was doing native. Everything was native, And then you fast forward to 2022, which is when I did these slides. The chart's even more stark than this, really. Most things are done with some kind of cross-platform tool. And a lot of the stuff that's really native or big apps, big public apps, that kind of thing. I call us the boring metal, which is not a great name because it's offensive to people we're trying to have as clients. But it's the places like, enterprise stuff or smaller apps that are utility apps that are not big, AAA, whatever, Ubers. It's startups where the product isn't the app. The app is just some part of the product ecosystem, right? All these folks, this world's gone from native mobile. This is all cross-platform. And what I am pitching is that KMP with Shared Compose can really fill that gap, because it gives you those quote unquote cross-platform efficiencies, but you can have a native experience. And that's really where I think that with time and effort and really making this work well, Compose, optionally Shared UI, becomes the default option again. It's native is the default option. And that's really what we're talking about here. So thank you for coming.